I decided to do science videos because I wanted to answer questions that some of my students had, and I wanted to put into context laws of science that I have learned. Alright, in this video, I will talk about the law of definite proportions. Okay, so in order to do this, I will answer the question, is water that is taken from a river the same compound as water from a lake? Alright. When we are doing such an investigation, we would have to ensure that water taken from the river and the lake, that these are pure samples. The reason that this is important is because we would want to make sure that there are no contaminants present, right? So therefore, the river water is only river water and the lake water is only lake water. Because if there are contaminants present, this can affect the water samples, and therefore any conclusions that we would draw from it would be erroneous. Alright, what is the next important thing to think about? Well, what is a compound? Okay, so I have two pictures here of chemical substances. One is a compound while one isn't. Alright, let's look closely at them. Alright, for the first substance, we have one red particle joined to one blue particle, and it is the same for the other particles, right? So thus in this substance, it's always a 1-to-1 ratio of red particles to blue particle, right? But in the second substance, we notice that it is only made up of green particles, right? Thus a ratio cannot be used to describe it. Why is that? Well, a ratio is used only to describe two or more things, right? Which is a comparison between two or more things. So it cannot be used for a second substance. Okay, so which one is a compound? Well, the first substance is a compound. And why is that? Well, a compound has particles that are joined in a fixed ratio, right? And it is the same throughout the substance. Alright, so now that we know theoretically what a compound is, let us think about how we can do this experimentally as well. Alright, so in order to do this, I will show you another picture. Okay, so we are still looking at our compound, okay, and we see here that this is a picture of our compound at room temperature. But the second picture is a picture of the same compound when it has been heated. Okay? What do we notice? We notice that after it has been heated, the particles are separated. These individual particles have different properties from when they were joined together. Okay? So, for a compound, right, experimentally, if you pass heat, light, or electricity through this compound, it will break down into simpler substances, right, which will have different properties from when it was a compound. Okay, so why is this important? Well, this is important because we are trying to determine, if water is a compound and whether water is the same compound in river water and lake water. Alright, it was found out experimentally that if you pass electricity through water, it breaks down into simpler substances that are hydrogen and oxygen. So water is indeed a compound. But what we are trying to figure out is if this compound is the same in a river and a lake. Alright, how would we know if it is the same? Well, let's think about this a bit. If it is the same, then if we started with the same amount of river water and the same amount of lake water, and we pass electricity through it, if the amount of hydrogen and oxygen that is produced is the same, then we would know that the same compound is present in both sources. Alright, so in order to do this, I will choose two amounts of river water to use, and this will be the same amount of lake water that I will be investigating. The two masses that I have chosen are 100 grams of water and 59.3 grams of water. Alright, so these are the results here. Alright, so for river water, right, when the mass was 100 grams, we realize that 11.11 grams of hydrogen was produced and 88.89 grams of oxygen was produced. But notice for lake water that we have the same results. And when we pass electricity, through 59.3 grams of water for river water, the amount of hydrogen that was produced was 6.59 grams, and the amount of oxygen that was produced was 52.71 grams. And for lake water, we realize that the same 59.3 grams of water produce the same amount of hydrogen and oxygen. Therefore, we can say at this stage that the compound present in river water and lake water is indeed the same. But let's think a little deeper. We define a compound as a fixed ratio between particles that are joined. And this can be described in a mathematical relationship because we use ratio, and we said, for example, in the compound that we talked about earlier was a 1-to-1 ratio. So let us think about if we can simplify the relationship between hydrogen and oxygen. What is a mathematical relationship between hydrogen and oxygen? But just looking at this raw data, it is difficult to establish a pattern between hydrogen and oxygen. What one could do is that we could divide the mass of hydrogen and oxygen by the mass that is smaller. So we notice that for 100 grams, it would be 11.11 grams, would be the smaller mass here, while for 59.3 grams, the smaller mass is 6.59 grams, and in both cases, that was the mass of hydrogen. And notice that it doesn't matter whether we use river water or lake water because the values that we got for them were the same. So let's look at this closer. Alright, so for 100 grams of water, the amount of hydrogen produced was 11.11 grams, and the oxygen produced was 88.89 grams, and we passed electricity through it. So, divided by the smaller value, 11.11 grams into itself gives us a value of 1. While for oxygen, 11.11 grams into 88.89 grams gives you a value of 8. So the ratio here is from the ratio of oxygen to hydrogen here is 8-to-1. Okay? While for 59.3 grams of water, when we pass electricity through it, the amount of hydrogen that was produced was 6.59 grams, while the amount of oxygen that was produced was 52.71 grams, right? So if we divide by the smaller value, which was 6.59, when we look at hydrogen, 6.59 into itself gives us 1, and oxygen, 6.59 grams into 52.71 grams gives us a value of 7.998, which can be rounded off to 8. So, in this case, even though it's a different mass of water, we get the same ratio of oxygen to hydrogen, which is 8-to-1. This means that, based on this preliminary conclusion, that the mass of oxygen is 8 times that. 8 times the mass of hydrogen. But wait, we don't know if the mass of hydrogen or oxygen that was produced represents 1 particle, 2 particles, 3 particles, or more. Okay? And this would have an effect on the relationship between oxygen and hydrogen. Let me show you in greater detail what I mean by this. Alright, seeing that the mass of water, whether we use 100 or 59.3 grams, that the ratio was the same, we can choose any of these two masses to investigate further. The mass that I have chosen is 100 grams of water. So the hydrogen that was produced was 11.11 grams, and the oxygen that was produced was 88.89 grams. Alright, so for scenario 1, if we say that 1 particle of hydrogen represents the amount of hydrogen that was produced as 11.11 grams, right? And we say that 1 particle of oxygen represents all the mass of oxygen that was produced, which is 88.89 grams. Then the ratio of oxygen to hydrogen will be 88.89 to 11.11. So divided by the smaller value again, 11.11 into 88.89 will be 8, and 11.11 into 11.11 will be 1. So the ratio would be for oxygen to hydrogen would be an 8:1. But let's look at the second scenario. Suppose we said that 2 particles of hydrogen represent the mass of hydrogen that was produced, which is 11.11 grams. In order to get the mass of 1 particle of hydrogen, we would have to divide 2 into 11.11 grams, which gives us 5.555 grams. Alright? And say that 1 particle of oxygen represents the total mass of oxygen that was produced, which was 88.89 grams. Therefore, the ratio of 1 particle of oxygen to 1 particle of hydrogen in this scenario would be 88.89 to 5.555. Therefore, divided by the smaller value in this case would be 5.555 divided by 88.89, which gives us 16. And 5.555 into itself gives us 1. So the ratio in this case would be 16:1. In this case, it is saying that oxygen is 16 times greater in mass than hydrogen. But we would need more information in order to know the number of particles present in water, right? We will do this in the next video. But the important thing to take away here is that regardless of whether it was lake water or river water, the ratio of hydrogen to oxygen was the same. So therefore, the compound in lake water and river water is indeed the same. This concurs with the law of definite proportion, which says that a compound is made up of particles in a fixed ratio that is the same regardless of the source. If this video has been of any help to you, please press like, and thanks for watching.